Okay, look at your question 1. Well, you better know the answer for that. Bernice, question 1. Sulfuric acid. Yes, H2SO4. One product of the reaction with ammonium carbonate. Yeah, Bernice. What is one product? It didn't do that. Well, you ought to. Now, guys, you better know the reaction ammonium carbonate plus acid. It's basically a carbonate acid reaction. That means you would expect a salt, CO2, and water. So any of these products you get your mark. CO2 or water or salt. But of course in this case there's only one salt that is possible. So make sure if you decide to write a salt as the product, that is the only salt you can use. Do not just write the word salt there, it will not give you anything. So I repeat, this one is an acid plus carbonate reaction. Now the second one, sodium hydroxide, Bernice, formula. Yes, of course, NaOH, and the product with ammonium carbonates. Do you do that, Bernice? No, you have to do that. That is your alkaline plus ammonium compound reaction. So what products will you get? I think we've done this pretty often. You should get ammonia gas, water, and a salt. You can just write down in case you all miss it out. So basically this is an alkaline plus ammonium compound reaction. So you should get ammonia gas, water, plus another salt. Of course, in this case, only one salt is possible, and that is your. Okay, in this case, you can only form sodium carbonate. So you can't just write salt. Make sure you get the right salt. Okay. Okay, so number 1 is pretty standard. Everyone must get that right. Okay, Charlotte, you too. Yeah. Okay, look at number 2. You have mass, you have volume, and you're asked to find concentration. Well, there's only one formula if you look closely, and that is formula number 4. Yeah, pretty straight away, you should zero onto that formula. So, yeah, Hannah, what do you get for that? 2a part 1?
106.
Okay, make sure you get 106. If anyone needs me to work it out, let me know. Okay, otherwise I'll go on. Charlotte? Okay. Alright, look at part 2. What are you given? You're given mass, you're given volume. Calculate concentration. Except concentration in this case is mole per dm cube. So please be careful about this. In other words, I would suggest that you convert mass to moles first. And what formula to use? Formula 1, of course, convert mass to moles. Okay, and then from there, you work out your concentration using formula number 3. Of course, concentration is on the right in this case. Make sure you manipulate your equation correctly. Yep, Hannah?
2.29.
2.29. What is the MR?
0.294.
0.294. What MR do you get? Sodium carbonate. 90. 90. Oh, you better calculate carefully. Alright, if you calculate correctly, your MR should be 106. I don't know whether you got that. Alright, MR should be 106. Everyone must get the MR correct. So the correct answer for A part 2 is 0.25 mole per dm cube. Okay, so without doing out everything, 2A part 2 basically convert mass to mole, divide by mR. As I said, mR should be 106. So once you have that, calculate concentration. How to get concentration? Concentration is mole over volume. Okay, volume you are given already as 2 dm cube. Alright, yeah, you shouldn't have a problem. You should get 0.25. Yeah, you should get that concentration. Okay, 2B. Sodium carbonate and HCl. Oh, guys, you better get that right. Charlotte. 2B. What's your equation?
What? Na2CO3 plus 2HCl plus 2NaCl plus H2CO3
H2O you mean? Plus CO2. Okay, guys. Very standard, but I'll just write it out for everybody's sake. Okay, very standard. Carbonate plus acid. You should get your salt plus CO2 plus water. Okay, yeah, very standard. And I can guarantee you this kind of reaction is going to come out. Carbonate plus acid, 100% coming out. How many moles of sodium carbonate we read with 4 moles of HCl? Oh, too easy. Charlotte? Part 2? Yeah? Yeah, 2 moles, huh? Okay, make sure everybody get that. I don't think I need to explain further than that. Look at 3A. You have nitric acid. Anyway, they use the word solution there, so concentration applies. You have a concentration, look carefully, concentration is grams per dm cube. Calculate the MR of nitric acid. Oh, too easy. Question?
63.
Yup, 63. Make sure everybody has that. Calculate the concentration in mole per dm cube. Question?
2.
Yeah, you should get 2 moles per dm cube. Oh, in case anybody wonders, you can use the equation 5, which I kind of mentioned last week. Occasionally, this can be useful, even though not all the time. Okay, so that is equation 5. You are given concentration in gram per dm cube. You know the MR? Yep. Just divide by the MR and you get your concentration in mole per dm cube, which is in this case 2. Okay, part B. Magnesium carbonate react with nitric acid. So you see this over and over again, acid plus carbonate. So make sure you recognize the reaction. How many moles of magnesium carbonate reacts with 1 mole of nitric acid? Question? Take one. 0.5, yes. Guys, you should get 0.5. Alright, based on the mole ratio. And how many moles of magnesium carbonate react with 500 cubic centimeters of 10 mole per dm cube nitric acid? Okay, for part 2. What are you given? Volume 500 cm cube. What else are you given? Concentration 10 moles per dm cube. Immediately, there's only one formula you should think of, and this is the one. Okay, that is the one you should think of. Concentration and volume are given. Calculate number of moles. Right, take one. 2.5. Good. B part 2 is 2. 2.5 moles of magnesium carbonate is needed. Okay. I should go on unless anyone has any questions. Now look at part C. Another nitric acid solution, diluting 1 mole to make 2 dm cube of solution. Come on, what are you given? You are given moles, you are given volume. What formula should you think of? You are given mole, you are given volume. Well, I would definitely look at formula number 3 first. Yeah, and precisely that's what you are needed to calculate concentration in mole per dm cube. Okay, that's what part C is asking you for. Just check, make sure your volume is in dm cube, which is, in this case it is. Yeah, so what's the answer? She went to? Yes, 0.5. Of course, anyone has questions, please voice out. This one is a rare question. Hydrogen carbonate. It doesn't come up that often, but anyway, just for interest sake, you may want to input in your knowledge base. This is hydrogen carbonate. It is an ion. HCO3 minus. So that is hydrogen carbonate. HCO3 minus. Occasionally it comes out. Okay, so what are you given? Sodium carbonate has a solution concentration of 2 mole per dm cube. What's the volume of the solution containing 500 grams? What are you given? You are given concentration, mole per dm cube. Okay, you are given concentration. What else are you given? You're given mass, 500 grams. Mass is tricky. You can have this, probably not. You can have this. Alright, so what should you do? Well, they ask for volume, right? Volume is here. So I think it makes sense to be using formula 1. Find the number of moles. And the number of moles, you go to formula number 3. And that allows you to solve for volume. Okay, so basically you're using formulas 1 and 3 only, rather than number 4. Hannah, what answer do you get? 2.36, yep, good. 2.36. Again, check your units, dm cube. Now, as I always say, try to stick to dm cube for volume unless the question